Right, I've been experimenting a little. I've disconnected one of the run coils. So I'm now running with 14 run coils. I looked at Poppy's Sambu Express where he commoned up the end run and put them across all the transistors. He actually had 8 run coils and 10 transistors. So I decided to actually put the spare transistor onto one of the circuits. So one circuit's actually onto 2 transistors. So I haven't actually commoned them all up, but I suspect that might be beneficial. Because in fact, if I disconnect that pairing, so I just disconnect the spare transistor. There we go. That's where they're disconnected. That's where they're connected. Disconnected, connected. So at least 100 milliamps better with it connected. Although that varies depending on the state of the batteries. I'll just reconnect that properly with both hands. So it's now reconnected. I've got one run coil driving 2 transistors, and that seems to be a benefit, which rather surprises me. So I'll probably experiment with commoning them all up, which will actually reduce the amount of wiring, because I can common them at that end and just run one big fat wire instead of lots of possibly fat wires. Anyway, so commoning them up does seem to be beneficial. I don't know if there's any current about and there's any transistor switched on. I guess it's beneficial. So whichever ones are switched on will, well, I would have thought they all switch on at the same time, but they might differ. Anyway, here is my generator coil, currently disconnected. I've currently got 9 lights connected with the capacity to smooth it out. The capacitor is probably much bigger than I need. It's the only one I've got. I just some time ago bought the biggest Maplin cell in my local store. It's a 2200 50 volt capacitor, and I'm currently driving 9 12 amp 30 milliamp bulbs. It will drive more, but the voltage drops off, so they go a bit dim. They're reasonably bright. We're almost 9 volts. And if I disconnect the lights and leave the capacitor, I'm getting, but it varies. It seems to be going up actually. Maybe that's as the capacitor charges. So well over 11 volts now. It was only about 9 when I started. Although it does seem to drop off. I don't know if that's as the capacitor charges or whether the capacitor is leaking. It's a brand new capacitor, so it shouldn't be too bad, I suppose. Anyway, the cost of this, though, is bigger than I expected. Sometimes I seem to get a change in the charge current. Sometimes I don't. So I guess that's nothing to do with this, really. I get a change in the draw current of about 150 with just the capacitor connected, and oh, that must have drained the capacitor. Ah, is that what affects the voltage? No, hold on, that's the wrong connection. I need to connect this properly. Can I do it single-handed? No. Yes! If I disconnect the lights, yes, it must be to do with the capacitor charging. Difference there. However, right, with the lights connected, the difference is quite large on the draw current. That's what, 1.85? That's gone up to 2. Let's connect more bulbs. So that's a 20 running. So 1.85 without and 2.2 ish. Keeps changing. So that's down to, oh, that's 1.8 now. That's all over the place again. 1.9, 2.2, so it's at least, it's over 300 milliamps with 20 bulbs and a capacitor. So that seems quite a cost. So I don't know if using that to back charge the run battery is going to be beneficial given that cost. Is it going to put back more than 350 milliamps? I'll only know if I try it, I suppose. Oh, perhaps I should stick an ammeter on that to see what sort of current draw I'm getting. Yes, I think I'll do that next. Right, I've moved my ammeter, and in fact I'm getting 310 milliamps from this generator coil. That's with 20 bulbs. If I take the bulbs out, oh, it drops to virtually nothing. So yes, 300 no, it's just changed slightly. Oh, it's gone up. Why did that happen? Suddenly I'm getting 400. Ah, that's as the voltage has actually just gone up. So is this as the capacitor charges? Oh, it's a big jump. Well, if I'm getting 400 milliamps out and only, oh, I should have done it the other way around, shouldn't I? Let's change these over so I can actually compare directly the change in the draw current. Right, so I've moved my ammeters around. So this is the current from the generator coil. And in fact, I'm getting nearly 400. That's 380. I'm on the 500 milliamp range. That's 385 milliamps. Now, the cost of that, if I disconnect what's the easiest way of disconnecting this? I'll disconnect one side of the alternating current. Well, that's the easiest way. Right, so with it off, I'm getting 190. With it on, 225. So it's about 350. So it's costing me about 350 draw current, and I'm getting, it's gone up again, that's over 390, that's about 390 now. So I seem to be getting more out than I'm putting in, which is brilliant. Oh, I like that. If I take less load though, let's disconnect Let's go back down to 9. Presumably the current drops appropriately. So increase the load and benefit is great. That is fantastic. So if I common up the transistors and use multiple generator coils, maybe I'll get a better setup. Oh, I like the look of that. So, brilliant. I need more ammeters now. I've only got 2 working ones. I need at least 3. Anyway, so that's actually looking very promising. So, for a cost of, oh, that's nearly 400 this time. That's 2.25. So I'm getting 400 out, and I'm putting just under 400 in. Brilliant. I'll be back.